You're welcome to Iniking video tutorials. In the next couple of video clips, we'll be looking at polygons within the scope of the secondary school mathematics. A polygon is a plane shape bound on all sides by straight lines, starting from a triangle, the quadrilateral, the pentagon, hexagon, and several others. We are going to be looking at some features or properties of a polygon within the scope of the secondary school mathematics. In this particular video clip, we are going to look at the following. We understand the meaning of the interior angle of a polygon, the exterior angle of a polygon, the relationship between the interior angle of a polygon and the exterior angle of the polygon. We'll also look at how to obtain the sum of the interior angles of a polygon and also the sum of the exterior angles of a polygon. At the end of this video clip, we should be able to obtain values for the sum of the interior angles of the listed polygons: the triangle, the quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and the decagon. And also we'll be able to know what is the sum of the exterior angles for each of these polygons. So let's set out. What is the interior angle of a polygon? By interior angle of a polygon, we simply mean the angle between two adjacent sides. I take, for example, there, that angle, let me call it theta, is the interior angle of a polygon. What then is the exterior angle of a polygon? To demonstrate the exterior angle of a polygon, I'll need to extend one of these sides. If I extend this side, for example, the angle created there outside is called the exterior angle of the polygon. Let's call that angle alpha. Of course, I can create another exterior angle by extending this side, for example, and that will also represent what? The exterior angle of the polygon at that point. So we can have several exterior angles. I can call that alpha 1. I can call this alpha 2. So now we know what the interior angle of a polygon is and what the exterior angle of a polygon is. The interior angle is simply what? The angle between two adjacent sides. That then is a relationship between the exterior angle of a polygon and its interior angle. As you can see, the exterior angle of a polygon, theta, in this diagram, and the exterior angle, alpha, both make up the straight line. And of course, in basic geometry, we know that angles on a straight line sum up to give us 180 degrees. So you will agree with me that my theta here plus the alpha will simply give me 180 degrees, which means that what? That the relationship between the interior angle of a polygon and its exterior angle is that what? That is sum up to give us 180 degrees. So that's our conclusion there. The exterior angle of a polygon and the interior angle sum up to give us 180 degrees. Our next objective is, how do I obtain the value of what? The sum of all the interior angles. I take this angle, I take the other interior angle, I take this and there, including my theta. What will be the sum? We have an expression for that. The sum of the interior angles of a polygon is simply obtained by multiplying 180 by number of sides n minus 2. So simply take the number of sides, say for example a triangle which has 3 sides, subtract 2 from it, and multiply by 180, and of course you will agree this will be what, 180 times 1. You can do that for all the polygons and you have the sum of the interior angles. Of course you will agree with me that if you try that for a quadrilateral, it should give you 360, just as we know that the sum of the angles in a square, a parallelogram, a trapezium, a rectangle, all of them give us what? Total interior angle of 360 degrees. So that's the relationship, or so rather, that's the expression when we want to obtain the sum of the interior angles of a polygon. So that's the summary of that. How about the exterior angle? Now, from basic geometry, we found out that if we take all the exterior angles, let's say I have another exterior angle there, I have one this way, let's call this alpha 2, alpha 3, let's say I have another one here, I call that maybe alpha 4, and of course another one this way. From simple geometry, we obtain, I call this alpha 1, we obtain that the sum of the exterior angles, alpha 1 plus alpha 2 plus blah 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 up to alpha 5 in this case, because we have a pentagon here, is equal to 360 degrees. Now please take note that the sum of the exterior angles has nothing to do with the number of sides. So irrespective of the number of sides of the polygon, the sum of the exterior angles will always give us 360 degrees. So yeah, that's it there. If I sum here, alpha 1 plus alpha 2, alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus, alpha 5. All the exterior angles, if you add them up, it will give you 360 degrees. Whether it's a pentagon, a hexagon, a nonagon, a triangle, or a quadrilateral, they will always sum up to give us what? 360 degrees. So that's the summary for that. The sum of exterior angles of a polygon gives us 360 degrees. So far we have seen the relationship between the exterior angle and the interior angle, that is sum up to give us 180 degrees. And the sum of the exterior angles of a polygon sum up to give us 360 degrees. And of course, to obtain the sum of the interior angles of a polygon, we simply carry out what? The multiplication of 180 times n minus 2, where n represents the number of sides of the polygon. Next, we introduce the concept of a regular polygon. When do we say, or when do we describe a polygon as being regular? Now, a polygon is said to be regular if all its angles, that's the interior angles, and all its sides, the length of the sides, are equal. So you can say a regular polygon is what? An equiangular and equilateral polygon. You can see here all the angles, theta, they are all the same. Of course, if the angles theta are the same, automatically we expect also that the exterior angles also will be the same, because they are all 180 minus, rather, so they both sum up to give us 180. So if you like, you can also say that the exterior angles of a regular polygon are what? All equal. So our summary for this is that what? That for a regular polygon, all angles, interior angles or exterior angles and lengths of sides are equal. Now remember we said earlier that the sum of the exterior angles of a polygon are equal. Sorry, sum of the exterior angles gives us 360 degrees. Now that we are saying that for a regular polygon that all these angles are equal, then I can simply say this is alpha plus alpha plus alpha plus alpha plus alpha. I take off the subscript of 1 to 5, and that is what? 360 degrees. Since they are all equal, I can simply say this is what? 5 times alpha. We have 5, of course, is the number of sides, which of course gives us the number of interior angles and the same thing as the number of exterior angles. And this is 360 degrees, which means I can easily obtain the value of one exterior angle for a regular polygon once I know the number of sides by dividing by the number of sides. Like in this case here, I divide by 5 for a pentagon. And if I divide this, I will have, I think this is 72 degrees, which means the exterior angle for a regular pentagon is 72 degrees. What do we simply do there? 360 divided by number of sides. So of course you can simply do what? Say, oh, exterior angle is what? It's 360 divided by number of sides. For a regular polygon, please take note. For a regular polygon, you can easily obtain the exterior angle by dividing 360 by number of sides. And of course, you can easily from there get your what? Your interior angle. So let's write this in a neat form. There we are. Yes, so that's it for a pentagon. The exterior angle is what? 72 degrees. So we now do what? We concluded that therefore to obtain the exterior angle of a polygon, one exterior angle, what do we do? Simply divide 360 by n, where n stands for what? The number of sides of the polygon. Let's still advance. So that's the summary there. The exterior angle of a regular polygon is what? It's simply 360 divided by number of sides. Of course, you know you can play around here. You can take your number of sides to the left and bring your exterior angle to the right. So if you know the exterior angle, you can also use that to calculate the number of sides by dividing 360 by the exterior angle. That will also give you the number of sides of the polygon. I'm sure that's quite straightforward. So far, let's take our overall summary. So far, we have seen, again, exterior angle plus interior angle add up to give us 180. Don't forget, sum of exterior angles of a polygon gives us 360 degrees. To obtain the sum of the interior angles, we use the formula 180 times n minus 2, where n represents number of sides of the polygon. And then we have said that the exterior angle is simply what? 360 degrees divided by number of sides of the polygon. Let's quickly use the formula there to obtain the sum of interior angles for some of our polygons, starting from the triangle, so that we can fill up the table we had before. So you can see here, for a triangle, our number of sides is what? 3. So we have 180. We've done this before. 3 minus 2, and that gives you 180 times 1. So that's it for a triangle, 180 degrees. For a quadrilateral, you will have consider a quadrilateral has 4 sides. So we have the 180 times 4 minus 2. And that is what? 180 times 2. You will agree, of course, for a pentagon, which has 5 sides, we're going to have 180 times 5 minus 2. And that gives us what? 180 times 3, which is 540 degrees. So let's bring that in. That's for a pentagon. Now you can do the rest for yourself. For hexagon, we have that. And also we have for heptagon. Now let's transfer this to our table. If we transfer this to our table, there we are. We have that for a triangle, the sum of interior angle is 180. For a quadrilateral, 360. For a pentagon, 540. For hexagon, 720. For heptagon, 900 and down. And if you can observe very well, you find that the difference is always 180 degrees. If I say 180 plus 180, I have 360. I add 180 to 360, it gives me 540. I add 180 to 540, I get 720. So you can just do that till you get down to the decagon. But what about the sum of the exterior angles for a triangle? Earlier on we said that the sum of the exterior angles is the same irrespective of the number of sides. That is always, it always sum up to give us 360. So each of these will take 360 degrees each. It doesn't matter what the number of sides of that polygon is. So we can fill that up, and that's it. Sum of exterior angles 360. And we have the sum of the interior angles for the triangle down to the decagon. So that's it for this clip. By the next clip, we'll use what we have been able to arrive at here to solve some problems. Let's see then.